All right, this is our last lesson of 1050. So binomial expansion. A binomial is simply a polynomial with two terms. In this section, we are interested in powers of binomials for the form of a plus b to the n. Okay, and n are your whole numbers, so 0, 1, 2, 3, 4, keep going. So the two that frequently come up that we should know is a plus b squared, which we know is a squared plus 2ab plus b squared. And our cubic is a plus b cubed. So the pattern is a cubed plus 3a squared b plus 3ab squared plus b cubed. So if we were to simplify this in terms of our cubic and our squared, what I want to keep in mind here is when I do this cubic, my a part for the cubic is a, and my b part is -3. So when I plug in for my a's and b's, I have a cubed plus 3 times a squared, and our b is -3. Now for my next term there, I got plus 3a to the first, and our a is a, and b is -3, and that's squared, plus our b, which is -3 cubed. And that is our cubic. Now, of course, we're going to go minus a times. Now, for our squared here, our a is actually 2a, and our b equals -9. So now when I replace it up here, we have 2a squared plus 2 times 2a times b, which is our -9, plus our b squared, so -9 squared. And that's writing it out and expanding it. So let's see if we can simplify that. I'm going to simplify this inside first here, which is a cubed. -3 times 3 is -9, so -9a squared. -3 squared is a +9. +9 times 3 is a +27a. And -3 cubed is a -27. Minus a times a. 2a squared is 4a squared. Now let's look at this. 2 times 2 times -9, so that's -36a. And -9 squared is a +81. Now we're going to distribute and combine like terms. So I will distribute all of that. So 4a cubed minus 36a squared plus 108a minus 180. And then now we're going to distribute a -a here. So that's a -4a cubed positive 36a squared minus an 81a. Now, if we combine like terms, we find that we have a lot of terms that are canceling out, leaving us with 27a minus 108. Crazy to believe that this huge expansion just comes out to two terms. All right, so what if we were to go backwards? Well, the one thing I want you to keep in mind is that this is cubic, okay? And if we look at our cubic, we see that the a is cubed first and the b is cubed in the end. Okay, so I would say x is our a, and 2 cubed, so 2 is our b. So let's see if that works. The next term would be 3 times a squared. Well, a is our x, right? So x squared times b, well, b again is 2. Did this come out to 6x squared? It did. Let's try our next one. The next one says 3 times a, which is x, times rb, which is 2 squared. Does that come out to our 12? Well, 2 squared is 4. 4 times 3 is 8. So that worked. Okay. Again, how I recognize that is I started with the a term and the b term and see if it went together. Now, if we're talking about cubic in general, let's talk about 125. What is the cube root of 125? Well, it is 5. So now that we know this is our cubic, we can go backwards and say a plus b cubed. Well, again, what was our a? X. Our b was 2, and that is cubed. Now we can solve. How do you get rid of a cube? Cube root it, giving us x plus 2 equals 5. So x equals 3. So those are two ways that we can use some common binomial expansions, especially common ones that come up the most, which is our squared and our cubic, okay? Now, what if we go further, though? How can we expand this? Well, what we can use what's called as Pascal's triangle. The idea with Pascal's triangle are these are the coefficients that are in front of each term in expansion, okay? So what I want you to keep in mind with the Pascal's triangle is that we start, the first row starts with as n to the 0. And think of that. Anything to the 0 is always the value of 1. So if I said a plus b to the 0, we know that's 1. Okay, just like the next line would be then n is to the first. So it's our exponent, right? So that would be a plus b to the first, which is just 1a plus 1b. Okay. Now, this is the idea of our rows. What I want you guys to see is the pattern for the Pascal's triangle. Okay. Because this keeps going as n to the second, or n equals 2, n equals 3. And remember, these are the exponents. So what if I said 4, 5? What if I said we were doing a binomial to the 6th? How would I know the next row? Can you see a pattern that's going on? What if I start putting in these little lines? You guys see what's going on? Hopefully you're saying, well, no matter what, there were ones on the outside. So I'm going to do ones on the outside. But my next term takes the upper 2 and then we add them. So 1 plus 5 is 6. 5 plus 10 is 15. 10 and 10 is 20. 10 and 5 is 15. And 5 and 1 is 6. And we can keep going and going and going. Hopefully you don't have to go that far because it gets really messy. All right, so using Pascal's triangle to expand, the exponent identifies what row. Remember, we start at row 0. You should use. Identify the a and b part. And we know we can have numbers or we can have variables. Use Pascal's triangle to determine the coefficients. Remember, I said those were the coefficients in front of the terms. And now there's another pattern that happens, and we can see it with the cubic. Let's go back. If you look at this, a cubed is actually a cubed times b to the 0, because b to the 0 is 1. And then if you look at the exponent for the a, it went down by 1. 3, 2, 1. And here, 0. And if we look at the b exponent here, we get 0, 1, 2, 3. So start high with the a, low with the b, and move by 1. The other thing I want you to notice is that the exponents added together will always be the exponent of our binomial. Okay. So let's see what we can do with this. So we have the fourth. So you want to look at the fourth, n equals 4, not the fourth row, right? N equals 4. And when you see n equals 4, you see the coefficients are going to be 1, 4, 6, 4, and 1. I spread them out because we still need to put an a and a b value with them. Now, if I look at this binomial, my a is going to be 2x, and my b is going to be -3. All right, so we're going to start high with the a value, low with the b. So a, we have 2x, and we're going to start with the highest exponent, which in this case is 4. Every term, I will go down by 1. Now, I am still going to put to the 0 just because I want you guys to see the pattern. Eventually, you won't have to because you'll know it. Next is our b. I'm going to start at 0. Now, also with these coefficients, guys, automatically put a plus sign for now. Will it stay a plus sign? No, not necessarily. And you'll see it in this one. Because that now will be -3 to the first, -3 squared, -3 to the third, and -3 to the fourth. And as you can see, our exponents add up to 4. Now, in your calculator, this is the best way I think you should go about. Of course, I've got a higher calculator than you guys use, but you're still going to do it the same way. You're going to have your coefficient up front, parentheses 2. Now, do not use your variables because variables don't have a value. So you're just doing the numbers. Close parentheses to the fourth, -3 to the 0. Again, you won't have to do the 0, 1 when you get in the habit. Enter. We get 16. So I get 16 from a number, but now I look at my variable. Those were x to the fourth. All right, let's do our next one. We have 4 times 2 to the third times -3. Oops, I didn't go down. To the third times -3 to the first. And what do you know? There is our negative. So it's -96. I look at my variables. I have x cubed. Now, when you keep doing that, you'll end up with 216 x squared minus 216 x plus 81, and that is our answer. All right, let's try it again. Now this is the fifth, so we're looking for n equals 5, and that is the row with 1, 5, 10, 10, 5, and 1. Hopefully I left myself enough room. My a value is a. My b value is actually -b. I'm going to do my a's first. Start high, right? So a to the fifth, a to the fourth, a to the third, a to the second, a to the first, a to the 0. Let's do our b. Negative b to the 0, negative b to the first, negative b to the second, negative b to the third, negative b squared, negative b. I went down again, right? This should be 4, and this should be 5. Okay, because they all add up to 5, right? Yep. Now be careful with this because the negative is a negative 1. Okay, so when you plug this in, make sure you have parentheses around the negative 1 before you do that exponent. We end up with a to the 5th. Here, the negative 1 stays a negative. Negative 1 times 5 is a negative 5. If we look at our variables, we have a to the 4th, b to the 1st. Next one, this negative 1 squared becomes a positive 1. So I have positive 10, a cubed, b squared. Negative 1 cubed is a negative 1, so negative 10, a squared, b cubed. That negative becomes a positive, so 5, a to the first, b to the 4th. And then this is negative, so negative b to the 5th. And we are done. Now the great thing about a plus b is that we're actually not having to do any calculations because we have positive 1. So we end up getting a to the 6th because 1 is the coefficient. The next coefficient is 6. A to the 5th, b to the 1st. The next coefficient was 15. A goes down 1, b goes up 1. Next one was 20. A goes down 1, b goes up 1. Remember, they're all adding to 6. Then we go 15. A squared, b to the 4th. 6, a to the 1st, b to the 5th. And last but not least, b to the 6th. So that's using Pascal's triangle to expand. Now let's talk about the binomial theorem because there are other ways to expand things with, I guess, less work. The binomial theorem provides us a way in filling the missing terms, okay, one at a time. There may be occasions that we require only one term, say the 5th term, in an expansion. And the binomial theorem allows us to find that single term. Before proceeding, let's introduce what factorial is and how it's noted. So really quickly, what this paragraph is saying is binomial theorem, which I'm going to introduce to you in a little bit, helps us find the coefficient in front other than Pascal's triangle. Okay. Now, the other thing to keep in mind is, yes, they even said it allows us to find a single term. Are you always going to have to expand a binomial out? No. Some questions might say 2a minus b, that binomial, to the 5th, but I want you to give me the 3rd term. Do you want to write out the whole thing and do it the same every time to find that 3rd term? No, we're going to use the binomial theorem to help us out. So now let's go into factorials because we use factorials in binomial. All right, factorials are notated by an exclamation mark. Okay, it's not an excitement mark like in English. Well, it is excitement, right? But it's a mathematical function, I guess we should say. So the idea is that it's a non-negative integer that we're looking at. So 0 factorial, even though you want to say 0 exclamation mark, It's not. You say factorial equals 1. That's an automatic thing. Now, what we can do for n factorial, 1, 2, 3, 4, 5, is show you what that actually represents. So what factorial means is that we're going to multiply by all the numbers lower than n, okay? All right, so what we're not going to do that. We're just going to go into example 5 and I'll show you how that goes. Okay, so 9 minus 3 is what? 9 minus 3 is 6. So I'm left with 6 factorial. So if I asked you to evaluate what that means is we're saying 6 times 5 times 4 times 3 times 2 times 1. So factorial says you're multiplying by all the numbers less than that all the way to 1. So when you do that out in your calculator, we get 720. Now we're going to break this down. 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And if you look, what helps us evaluate this quicker is these terms cancel out. So we're really left with 5 times 4 times 3, which is 60. Now let's look at 10 factorial, 8 factorial. So if I write it all out, I get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What happens? Well, all of these cancel. That was a lot of writing, right? We get 10 times 9, which is 90. All of a sudden, you're like, wait a second. I don't want to do that for D. I don't want to write 100, 99, 98, 97, do all that, right? That would just be redundant. Because can you see a pattern that's going on here? I see 2 factorial is in 5 factorial, right? It's almost like a subtraction of it. So what I would do is look in comparison. I see 8 is down here. So I'm going to do 10 all the way to 8. So 10 and 9, and now 8 starts repeating, and I can get rid of that. So when you have that thought in your head, and I have 100 factorial, what I'm going to do is write all the way down to 97. So I have 100 times 99 times 98. Now I'm not going to write 97 because that cancels that 97 right there, leaving me underneath still 3 times 2 times 1. And now I can calculate that out in my calculator. And I get 161,700. All right, so that's a little lesson on factorials, and that's what we're going to use with the binomial theorem. So the binomial coefficient, that's what we're looking for, right? For non-negative integers n and k, where n is greater than k, and the binomial coefficient reads as this: n chooses k, is defined by this. So anytime we see this, we're going to put n factorial over k factorial times n minus k factorial. So in this sense here, we have 6 factorial over 0 factorial times 6 minus 0 factorial. Now remember from the other page, 0 factorial will always equal 1. So really, if we were to simplify this, I would have 6 factorial over 6 factorial, right? Because 1 times 6 factorial is itself, which equals 1. All right, let's do the next one. So this tells me it's 10 factorial over 7 factorial times 10 minus 7 factorial. So let's write this out just like we were doing above here. 10 times 9 times 8, but I'm not going to write 7, 6, 5, 4, 3, 2, 1 because that's covered by this 7. But 10 minus 7 is 3 factorial, which is 3, 2, 1, which leaves us with 120. All right, let's set this one up. 4 factorial over 4 factorial. 4 minus 4 factorial. Well, did you guys see that this is 1? So I'm really looking at 4 factorial over 4 factorial, which is 1. 7 factorial over 3 factorial. So now I'm going to start doing some stuff quicker, right? I know that I'm subtracting n minus k. N minus k would be 4 factorial. So when I look at this, I'm looking at 7. I'm going to get rid of the bigger one first, which is this 4. So 7 times 6 times 5. Now I'm not going to do 4 because it's covered there. And then all I need is 3 times 2 times 1 equals 35. 7 factorial all over 4 factorial. And then we have 7 times 4. 7 minus 4 is 3 factorial. And what do you know? It's the same problem. So our coefficient happens to be the same in those two terms. All right, so how does that help us? The binomial theorem for any positive integer n, a plus b to the n, is the sum, right? That's how we were doing the expansion of it. But we can also think of it as the coefficient that's in front of every term is our binomial coefficient, right? So we can do the factorial stuff for that. If you want to use a formal theorem, go for it. But the binomial coefficients are also the rows in the Pascal's triangle. Okay, so the idea is you get to choose which one you want to do. Unfortunately, with Pascal's triangle, you have to memorize a pattern, and sometimes you have to do it all the way out to make sure. But what we're going to do is we're going to practice using the binomial theorem just so you can have that choice of which way you want to do it. Because again, if I were using Pascal's triangle, I would probably use it all the way out, and then I would have to actually count that term, so on and so forth. Now, the idea about this is the term itself. Do you guys see that this might be the first term, but my k in my first term is 0. And remember, it's n over k, n over k. So be careful with what the k is. It's going to be 1 less on what your term is. So on number 7 here, even though we're finding the 7th term, it means k equals 6. So when I write this out, I get 10 over 6, and then I have to remember my a and my b because this is my a and b. So my a will always be your n minus k, and your b will always be k, which in this case is 6. Okay, so right here our coefficient would be 10 factorial over 6 factorial. Subtract them, right? 10 minus 6 is 4 factorial. Then we have a to the 4th, b to the 6th. You know you've done something right because remember the exponents have to equal up to that exponent. So 4 plus 6 is 10. So we're good there. Now we actually have to write this out. So 10 times 9 times 8 times 7. That covers our 6. We have 4 times 3 times 2 times 1. So that means that our 7th term in this expansion would be 210 a to the 4th, b to the 6th. Now, if you look back at Pascal's triangle, we could have looked at the 10th row. Wait, we never went to the 10th row. We could have gone to the 10th row, and which would be, yeah, n equals 9. We would go to that row, and you will see that, hey, 210 is right there. And that only works, though, when it's to the A and B. If it was 2A or 2B, it would change a little bit. So that's where the binomial theorem is actually a little bit better, though sometimes the more work we do, we make sure we don't make mistakes. So let's see what happens here. It says, consider that 2x minus y equals 7. Find the terms in the expansion that contain x cubed and y to the 5th. So by the way, these are 2 problems, okay? So when I want x cubed, well, think of it. If we're doing 7 and we need x cubed, that means we're going to have this, our a term is going to be 7 minus what is 3? 7 minus 4 is 3. So in other words, our k is going to be 4. Now, if you really wanted to look at that, you could expand it and say, okay, this would be x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, and then we could have said k is 0, 1, 2, 3, 4. So k is 4, which means our binomial coefficient would be 7 there and 4 there. Okay. By the way, I wrote this down as negative y because negative y is our b. 2x is our a. Negative y is our b. So we have to be careful because now we have this coefficient to an exponent. So this is going to be 7 factorial over 4 factorial 3 factorial. Remember, we subtract those. Then, is this to the 3rd, right? Well, 2 to the 3rd is 8x cubed. Negative 1 to the 4th is a positive, so we don't have to worry about the negative there. And then y to the 4th is just y to the 4th. Now, when we do this calculation and we multiply it by 8, we end up getting 280 y cubed, x cubed, y to the 4th. All right, let's look at what contains y to the 5th. Well, this would be y to the 0, y to the 1st, y to the 2nd, y to the 3rd. We had y to the 4th already, right? So y to the 5th would be k equaling 5. So here we would have 7, 5. We have our a value, 7 minus k, and then negative y to the k. All right, so we have 7 factorial over 5 factorial times them subtracted, which is 2 factorial. Now we have 7 minus 5 is 2. 2 squared is 4x squared. There we go, guys. Sorry. Why did I put k here when we know k is 5? Now something to keep in mind here is negative 1 to the 5th is negative 1. And then we have y to the 5th. So when you calculate all this out, remember that you're calculating our binomial coefficient times 4 times -1. And when we do that, we get negative 84 x squared y to the 5th. So what's great about this is you guys can choose to use the binomial theorem, or you can do binomial expansion by Pascal's triangle. You got to figure out what best fits you. And we are done.